Hello everyone. My name is Daiichi, and I will give you the lecture regarding the radiation and remediation activities. So, let's start today's lecture. Today's theme is environmental contamination caused by the accident of Fukushima Daiichi Nuclear Power Plant, Volume 1. Are you ready?
Mr. Daiichi, what are we talking about today?
Well, how about reviewing again the environmental contamination caused by the accident of nuclear power plant in 2011? By the way, do you remember the environmental contamination in the aftermath of the accident?
Well, I remember that it was expanded into very large area, but I can't identify the exact contaminated area.
Okay, no worries. Then, let's look back together, the history of contaminated area after the accident, based on the materials made open to public by national government. This is the map representing the result of airborne monitoring implemented by national government and calculated the air dose rate, to the data of June, 2012. The red area represents higher air dose rate, and air dose rate decreases in accordance with the change of color, yellow and green. And if blue becomes darker, the air dose rate becomes lower.
Wider range of area was contaminated than I expected.
The contamination level depends on the area, but it expanded to north, Tohoku area, and to south, eastern Kanto area.
But as assumed, the air dose rate is higher if it gets closer to the damaged nuclear power plant.
It is not in a concentric fashion, but it tends to be higher if it gets closer to the damaged nuclear power plant, as you mentioned. Higher contamination area expanded into northwest area from the nuclear power plant. Let's set a clock forward to see how the contamination level changed.
Half year passed. I see now more blue areas compared with June 2012.
Correct. It is, however, explained in the material published by national government, but airborne monitoring might be affected by snow. So, it is better not to pay attention too much to detail, but to the tendency, how the air dose rate changed as a whole. Okay, let's go further.
One more year passed. I think the blue area so much increased.
That's right. If you would like to see the transition more carefully, you can rewind the animation and confirm how it changed. Okay, let's move on to the next.
One more year, 3 years and 8 months passed after the accident. The air dose rate decreased further.
Yes, it's true. Let's go further.
One more year passed. 4 years and 8 months passed after the accident.
Yes, the air dose rate decreased further and the red area, which was spread in the northwest of the damaged nuclear power plant, became difficult to be identified.
One more year passed. Around 5 years and 8 months after the accident.
Yes, in Iwate Prefecture and Miyagi Prefecture, the color turned into dark blue, which means lowest category of air dose rate, other than area adjacent to Fukushima Prefecture.
One more year passed. 6 years and 8 months passed after the accident. I understand that the air dose rate decreased as a whole, but the decrease rate became slower, compared with the years shortly after the accident. Am I correct?
That's a very good point. The reason will be explained in the another lecture.
One more year. 7 years and 8 months after the accident.
Compared with 1 year before, the air dose rate decreased as a whole, but as you pointed out, the decrease rate became slower.
Okay, 1 more year passed. 8 years and 8 months passed after the accident.
Right. As a whole, no big change can be seen compared with the previous year.
1 more year passed, and more than 9 years and 7 months after the accident.
Correct. Well, areas with dark blue was apparently expanded, but no big changes seen as a whole. Let's review again the whole passage of time from the beginning. Okay, for the next, let's focus on the area more adjacent to the damaged nuclear power plant and look at the transition of air dose rate. We will start from April 2011, 1 month after the accident.
Only 6 months passed, but the air dose rate in the northwest area of the nuclear power plant apparently decreased.
Correct. The air dose rate decreases drastically, especially shortly after the accident, as we have already seen in previous slides.
1 year and 3 months passed after the accident. The air dose rates in the area, which were originally green or blue, also seems to decrease, compared with the previous time.
Yes, that's correct. Let's move the time forward.
Additional 5 months passed. Totally 1 year and 8 months after the accident.
Yes, the high air dose rate area, in the northwest of the damaged nuclear power plant, apparently became much smaller than previous time.
Additionally 10 months passed. Around 2.5 years after the accident.
Yes. Okay, let's move the time forward.
1 more year passed. 3.5 years after the accident. The blue area gradually became darker.
Yes, you see the transition very well. Let's move the time forward, about 1 more year.
Around 4.5 years passed after the accident.
The dark red area in the northwest of the nuclear power plant became difficult to be identified. Let's go further, 1 more year.
Around 5 years and 7 months passed after the accident. The blue color in the area, away from the nuclear power plant, got much darker.
That's right. The air dose rate became quite lower than previous days.
Around 6.5 years passed after the accident. The air dose rate apparently became lower than 2016, but I may not see so big change.
This is the same phenomena with the one we already saw in the transition in the wider range of area. With time, the decrease rate of air dose rate became less and less.
7 years and 7 months passed after the accident.
As a whole, the air dose rate decreased, but big changes can't be seen, compared with previous year, 2017.
8 years and 6 months after the accident.
Right. Dark blue areas apparently became larger, but not so big change can be seen.
Almost 9 years and 7 months passed after the accident.
Yes, there was apparently no big change. For our better understanding, let's look at them from the beginning.
By the way, Mr. Daiichi, why does air dose rate decrease with time? And there is one more thing I would like to ask you. Why does the decrease rate of air dose rate slow down with time?
Yes, you remind me of the important points. Today we talked quite a lot, so for today let's focus our study on the facts themselves, and let me explain the reasons in another lecture. So, let me wrap up my lecture by providing you the key points. Environmental contamination caused by the accident of Fukushima Daiichi nuclear power plant was expanded to a wide range of area, from Tohoku to Kanto Region. Especially, the northwest area of the nuclear power plant was comparatively highly contaminated. And as a whole, air dose rate gradually decreased with time. Its decrease rate, however, also slowed down with time. Okay, today's lecture is now dismissed. See you next time. In this channel, the useful information regarding the radiation and remediation will be provided to you. If you like it, please subscribe to this channel, and do not forget to click the like button.